So we're going to build a linear regression model in R using some housing data. So here we have the size of our houses, the age of our houses, and the price of our houses. And let's say we wanted to build a model that could predict price of house using size and age. So we're going to do this in R. So first we have to load our data. So we're going to go to Import from Excel, Browse, and then we're going to open the Excel spreadsheet containing our housing data. And then we're going to click Import, which will create a data frame named House, which will contain our data. So here we can see House in our global environment. And if we click on it, it'll pull up the data frame. So let's say we wanted to access the price column in House. So we do this by typing house $, which allows us to access a column in the data frame, and then price, if we want to access the price column specifically. And so this will return the price of all of our houses. Now, if we're going to predict for price is going to be our dependent variable. And we're going to follow this with size and age, which are going to be our predictors for price. Now, in order to build a linear regression model, we're going to wrap this equation in the function LM, which is a function that will build a regression model that can predict price from size and age of a house. Now we're going to wrap this in the summary function, which will show the results of our regression model. Now there are a lot of numbers here, but we're going to focus on just a few. The first being the R² value, which is a number that runs from 0 to 1. 0 meaning the model doesn't predict for price at all, and 1 meaning the model predicts for price perfectly. So in our case, our R² is 0.91, which means our model predicts for price pretty well. Next, we'll look at the p-value. If this is less than 0.05, this means that our R² value is statistically significant, which in our case, it is. Now we're going to look at the p-values for size and age. If this is less than 0.05, it means that the corresponding variable is a significant predictor for price. So in this case, size is a significant predictor, but age isn't. Lastly, we're going to look at the estimates for size and age. The larger this number is, the larger the effect the variable has on price. Also, if the number is positive, it means the variable trends in the same direction as price, whereas if it's negative, it means that the two go in opposite directions. So in summary, we have a statistically significant model that can predict for price very well. And then within this model, size is a significant predictor for price, whereas age is not. Hope this was helpful. My goal was to break this into very simple steps so you could try this for yourself on your own data. Let me know how it goes in the comments section.